All right, let's do this. So I just want to maybe illustrate that this is one of those graphs that you should be able to graph cold. That is, you should be able to graph y is equal to x cold, the identity line, all the time. Y is equal to x squared. Yeah, you know how to graph that, one of the fundamentals. Also, y is equal to 1 over x should have the ability to graph. There is a graph extra that I have attached here so you can practice. So let's look at this from a transformation perspective. You're able to transform the graph y is equal to 1 over x into any rational function y is equal to a over x minus h plus k, where the parameters of a, h, and k are those from the previous lessons, all from unit number 1, right? So for instance, here, if our function is if our parent function here is f of x is equal to 1 over x, that if I was to multiply my function by a, so y is equal to a f of x, what that would be y is equal to a over x, right? Because when you multiply 1 over x, so this a is a stretch by a factor of a. It's vertically stretching. Do we ever horizontally stretch a rational function? No, don't worry about it. It's all good, okay? So later on, I can perhaps show you how we're going to graph this. But let me consider this. These are our transformations. This should be on the top of your head. If a is less than 0, right? If there's negative in front, you need to reflect this. If h is greater than 0, then we need to shift it right. If h is negative, we need to shift it left. K up and down. So from this graph, okay, step 1. Graph y is equal to 1 over x, right? Because I need to have the ability to graph this, so I'm just going to move this up. I'm going to graph y is equal to 1 over x. Very quickly, I'm only talking about this function, not going to actually talk about the question. Remember, you know how to graph this cold. So I can see that my horizontal asymptote is y is equal to 0. Because the degree of my numerator is 0, the degree of my denominator is 1. My vertical asymptote for this function here, same thing, is it's going to be vertical asymptotes occur whenever the factors of my the denominator are equal to 0, provided that they are not canceled out. So x is equal to 0 is a vertical asymptote. I am just going to graph those using bright pink. And hopefully my asymptote will be nice and thin. There it is. So there's my vertical asymptote, and it's looking spectacular. It's dotted, it has arrows. My horizontal asymptote, it's looking equally spectacular. It has arrows. So I have the behaviors of my graph. Now remember, I'm going to erase this in just a second because you know how to graph this. And then I'm going to choose x values. The x values that I like to choose to draw a hyperbola. And by the way, these things are called hyperbolas. So I'm just going to choose -3, -1, -0.5. Why, you may be asking me? Why not? There is actually good reason why I choose these. And when x is equal to -3, the y value is going to be -1/3. To me, this illustrates the horizontal asymptotic behavior. What happens on the left? X is equal to 1. Well, it's kind of nice because it's just a point in the middle. Now this x is equal to 1/2. Y will be the reciprocal of 1/2, -1/2, which is -2. So I made a mistake. So sorry. I made a mistake graphing. So when x is equal to -1/2, my y value is -2. So I have 3 points graphed. Comme ça. And I've drawn my graph, and this looks spectacular. Now I'm going to try to keep this in mind when I'm going to be graphing this and transforming this later. And hopefully it's not going to be too hard. So when I graph the other points, there we are. So, and these points are going to be very important because mental math is going to tell me that you don't transform the function, you transform the points, and the function follows those points. All right. Let's get started here. Step 1, graph the hyperbola. Good, I did. So if I was to take a look at this function, what do I see? There's a negative front and side. If you want, you could write this out. You could write it as -3 x minus 2 plus 1. And what we're able to see is if we start off with the function y is equal to x, and if we apply, now I'm just going to write out my parameters a, h, and k. If a is equal to, well, let's do it with the first one. If a is negative, that would make a reflection about the x-axis. Now, if if the absolute value, if this ever comes, there it is. If the absolute value of a here is 3, this means that we are going to vertically stretch it by a factor of 3. So this is reflect about x. This means vertically stretch by, just realize that I'm a terrible speller when I'm in a rush, by a factor of 3. So let's get started on this. I'm gonna, maybe first things first, I'm gonna reflect this. If I reflect it, now you should be fairly familiar with reflecting, and all you're simply doing is the x values stay the same, but your y values are multiplied by -1. But yet, that's what it looks like. So this is my first reflection. Done. Now I'm going to stretch the function by a factor of 3. So 1/3 multiplied by 3 is going to be 1. This 1, now these are starting to be critical points here. -1, 1, if I stretch it by a factor of 3, it becomes -1, 3. Here is half 2 is going to be half 6. So this is what it's going to look like. Now notice that the horizontal and vertical asymptotes stay the same. That asymptotic behavior hasn't changed whatsoever. It will change when I shift the graph. I'm just going to do this for the other side. And the asymptotes, I have to make sure that I observe that asymptotic behavior. So there we have it. Hope I'm not going too fast here. I feel like we have learned this. And so I have a, by the way, a was going to be -3. So that implied that I need to reflect and stretch by a factor of 3. Here, I see h is equal to 2. If h is equal to 2, we need to shift this over 2 units to the, so I had this function here, and I just need to shift it 2 units over to the right. anyway, so this is getting to be a big ugly mess. But everything is shifted 2 units over to the right. That includes my asymptotes. So I'm just gonna, yikes. 2 units, not 3. Getting distracted in math. So everything's shifted 2 units over to the right. Now, I don't really love doing rational functions and transformations because there are cleaner ways of doing it, and that would be just graphing it. But regardless, I'm taking this point, I'm moving it 3 units over to the, 2 units over to the right there, taking this point here, moving it 2 units over, so it's going to be right there. Okay. Let's try that again. I'm just going to put a dot and move things 3 units over. This is very tough. I'm not going to lie to you. It's very, look how gross this graph looks. Okay? And maybe, just maybe, I'm going to stop after this because I don't know if I'm getting a lot of information from this. But what I'm able to see is that my graphs move, or they stretch, they reflect, and they move left and right. I'm just going to write here, I'm not going to write shift it, but k is equal to 1. K is this. So now what do I have to do? I have to take this whole big mess and my last graph and shift it up 1 unit. So I'm really not a huge fan of transforming functions that are rationals. It is overly complex. I think what some learnings that need to happen are like this. What I would do is I would simply write a is equal to -3, h is equal to 2, k is equal to 1. And the words to this are very important. Now recall that we're going to start off with the function y is equal to 1 over x, which has a horizontal and vertical asymptote. So our horizontal asymptote will be y is equal to 0. Our vertical asymptote is x is equal to 0. So I'm just going to draw those asymptotes really, really quickly. If I stretch this vertically by a factor of 3, this doesn't change the vertical and horizontal asymptotes. They stay where they are. Now h is equal to 2. If I shift everything over 2 units to the left, so my graph y is equal to -3x, my vertical and horizontal asymptotes are still the same. Or sorry, if I stretch it by a factor of 3. But if I shift it 2 units over to the right, what happens is that my horizontal asymptote stays the same, but my vertical asymptote moves 2 units to the right. So right now, my horizontal asymptote stayed the same. Sorry, and then my vertical asymptote moved over, it got shifted. How far? Well, it got shifted along with the whole graph 2 units to the right. And now k is equal to 1. My functional form will look like this. And my horizontal asymptote now moves up 1 unit. So basically this graph will have a new horizontal asymptote. and my vertical asymptote will be the same as the previous step. And really, if I was doing this, I would graph my horizontal and vertical asymptotes. Now you can plug in your x values into this function and graph your hyperbola.